SwiftUI Mastery Lingo Language Translator offers extensive training in creating language translator apps with Swift and SwiftUI, providing significant benefits. Enhance iOS development skills. Gain in-depth knowledge of iOS development, mastering speech recognition, language translation, and audio functionalities. Stand out in the job market with practical experience in building innovative applications. Demonstrated problem solving. Tackle complex challenges like implementing speech recognition algorithms and integrating translation APIs. Showcase problem solving ability and creativity sought after by employers. Career advancement. Unlock new career opportunities in iOS development with mastery of Swift, SwiftUI, and advanced features. Qualify for senior roles such as iOS developer or project manager with increased responsibilities. Academic excellence. Undertake impactful computing projects by developing language translator apps enriched with advanced features. Demonstrate deep understanding and technical proficiency to academic assessors, potentially leading to high academic recognition. The focus areas includes speech recognition, language translation, voice recording, playback of recordings, text-to-speech functionality, SwiftUI Mastery. The Lingo Language Translator includes the following 5 features: speech recognition, language translation, voice recording, playback of recordings, text-to-speech functionality. To demonstrate the app, I will convert from English to Spanish by typing in the text. Hello, how are you today? Now I will translate the text from English to Spanish by clicking on the Translate button. As you can see, the translated text is displayed within the translated section. To say the actual word, just click on the Say Word button.
Hola, ¿cómo estás hoy?
Now we can do the same thing using record. Now I will click on the record button and say, hello, how are you today? Hello, how are you today? Now I will click on the play button to play the recording. Hello, how are you today? Now I will click on the play button to play the recording. Now I will translate the recording I just done from English to Spanish. I will just click on the Translate button and then click on the Say Word button.
Hola, ¿cómo estás hoy? Ahora haré clic en el botón Reproducir para reproducir la grabación.
The app includes about 100 languages. These are the languages. This was a small introduction how to use the language translator that was created using Swift and SwiftUI. In this lesson, we will create our API class. The purpose of the API class is to submit text to be translated and to receive the translated text in the required language. The first thing we need to do is to create our iOS project. To create our iOS project, we have to select App and click on the iOS tab. Click on Next. We call the project Language Translator. Make sure that SwiftUI is selected for the interface and the language Swift is selected. Click on Create. Save it anywhere on the desktop or anywhere on your computer. Within your Xcode project, create a new class. To do that, we click on File, New, File, select select Swift File. Give the file a name, we just call it API. In Swift, a class is like a recipe for making something special with parts such as properties and actions such as methods. You can use this recipe to create as many of those special things as you want. For example, instances. You decide on your initial value for the parts using an initializer, and you can control who gets to see or who uses the parts within your class. To create our class, just type in public class API. The class has an action or method which is called translate text. Type in function translate text. This function has or accepts 3 parameters, and these are called selected source language, which is a string data type, selected target language, which is a string, and word, which is a string. Async string question mark. The function translate text takes in a source language, target language, and a word to translate. It asynchronously performs the translation and returns the translated word as a string. The actual translation logic needs to be implemented within the body, and that's what we'll do now. We need to create a variable called translated text, which is var translated word, which is a string data type, and it can be nil. So this declares a variable named translated word, and it indicates it can hold a string or nil. The next thing we need to do is to create our API key variable. And you just enter your API that we created in the first lesson. So just put your API key here. The next thing we need to do is to encode our word that we want to be translated. So to do that, we type in the following: let encoded word equals to word dot adding % encoding. So the purpose of using adding % encoding is that it enables the word to include spaces, .url query allowed. The next thing we need to do is to create the URL for the translation of the API request. Let URL string is equal to HTTPS translation .google APIs.com language translate v2 question mark Q, and now we apply our parameters, which is our encoded word. For example, the encoded word could be you want to translate hello from English to French. So the encoded word would include the actual words, such as English, hello, they want to translate. So it would include hello. That would be within your encoded word. Ampersand, target, equals selected target language. For example, there, the selected target language could be French. So we want the words to be converted to French. And then the source language selected source language could be English. Ampersand key equals API key. So that's where we apply our API key that's needed. Without the API key, the translations will not work. I'll just compile it. And we need to add a return statement. We'll do that afterwards. I'll just do that now just to make sure it's compilable. So to compile, you just select product menu and then click on build, and that compiles your application. It's compiled successfully, so that's good. The next thing we need to do is to assign our URL string into a URL variable, and to make sure that the actual URL is a valid URL string by converting it to a URL. And then if it's not a valid URL, the application will crash because it has to be valid. That's why we're doing false unwrapping. Next thing we need to do is to create a URL request with the created URL. So just type in let request equals URL request. URL. So now that we have a valid URL, we can then try or attempt to get a response from the server, from the service. So what we need to do is to send the API request and then wait for the response. So to do that, we just type in let data equals try await URL session dot shared data for request. On lines 28, the first thing that we do is declare a constant name, which is called data, to store the data retrieved from the URL request. The second thing we do is to use a try keyword that indicates that an error might be thrown during this operation, which is here. The await keyword waits asynchronously for the URL session data fetching to complete. So because we're communicating via the cloud or the web, it has to be done asynchronously. The URL session dot share data for request sends a request to the specified URL and fetches the data. Next thing we need to do is to create a catch block to catch any errors. We do that on line 30. Just type in catch, and then we just print out any errors that were caught. Error fetching translation. Error.localize description. And because there was an error, we just return blank blank, which is string. The return statement that we have on line 36, it shouldn't be blank, it should be translated word. and then we do like safe unwrapping. So if the translated word didn't include an actual word, we just make sure that we return a blank string. So the blank string will be empty if it's nil. I'll just compile it again. The next thing we need to do is to decode the response data into a custom object. So decoding is just like extracting information from the JSON payload from your web request and assigning the extracted data into an object that includes properties. So we do that now. Just type in let response equals try JSON decoder decode and we'll be decoding into my text mytext.self. My text is not created at the moment. We have to create that in our next lesson. And then we get the decoded data from our data variable. Because my text doesn't exist at the moment, let's rename that as self. And then put a little comment here. You need to create the my text class. That's what we do next lesson. Now not self, let's change it as string because self is incorrect. Let me compile it again. Yeah, that's good, it's compilable. The next thing we need to do is to extract the translation from our response. So to do that, we're typing let translations equals to response dot data dot translation. But because our my text object doesn't exist, we don't have access to the translation property of the data object. So that's another thing we need to do in our next lesson. So I'll just comment that out. And as soon as we create our myText object, this will be working correctly. Thank you for joining us. If you found this tutorial helpful, please comment, like and subscribe. See you next week.